everybody, let's tackle this last page, page 3 of the review packet. So in number 8, I'm asking for an equation of a circle. If we know the diameter is the square root of 11, what we really want in the formula is the radius. So the radius would just be half of that. So that would be the square root of 11 divided by 2. So just going back to, again, you should have these formulas written on your formula sheet. The circle is just x minus something squared plus y minus something squared is equal to r squared. So x minus 4 quantity squared, y plus 1 quantity squared is equal to r squared. So think about what that looks like. Square root of 11 divided by 2 squared is actually going to be, well, square root of 11 squared is just 11 over 4. So then our actual formula should look like x minus 4 squared plus y plus 1 quantity squared equals 11/4. Let's move right on to number 9. This time I'm giving you the graph of a hyperbola and asking you for the equation. So recognizing at this point, this must be an x squared. It's opened in the x direction. Opens in x. That must be an x squared parabola. Or, sorry, parabola. Hyperbola. Minus a y squared parabola. And we're equal to 1. So let's just start filling in the pieces here. Looks like our center is at 2, negative 3. So x minus 2, y plus 3 is where our center is. Now be careful about our scale. Can you see in the x direction we're going by 2's? So it looks like in the x direction we are going out to 4, even though it looks like 2 tick marks, that is actually 4, right? So that would mean we're going to have a 16 underneath the x. In the y direction, it looks like we're going up just 1 in the y direction. So then 1 squared is still just going to be a 1 here. So you really could get by without putting that divided by 1 at all in there. It looks like we need our the foci points. So that's going to be somewhere out here in the bowl of each parabola, if you will, each end of the hyperbola. So again, if I know that a squared is the 16 and b squared is the 1, remember we can use the actual correct looking version of the Pythagorean theorem to figure out what the c squared is, which tells us where the foci points would be. So c squared is equal to 16 plus 1, or c squared equals 17. So c would be equal to plus and minus the square root of 17. Oops. Equal to 1. So what that tells me, square root of 17, if we type this into our calculator, is approximately 4.1. So I'm going to go from my center point over 4.1. So it's going to be really close to those vertex points, and then back 4.1 to those vertex points. Now, I don't want you to tell me a decimal value for this. I want you to go at an exact value for these foci. So again, in the x direction, we start with our center of 2, negative 3 for the foci. And then I'm going to go from the 2, I'm going to add the square root of 17. And then for my second foci point, I'm going to go 2 minus the square root of 17, down 3. For the asymptotes, that's these gray dashed lines that we see here. So again, I just have to really kind of, count my rise and my run. So up 1 over 4. Again, be careful about the scale in x here. So I've got a y equals, for this guy, this is a 1/4, right, for my positive, going up 1 over 4. So 1/4 x plus b. I'm not quite sure. I don't want to guess where I'm crossing. So I do know for sure that the ordered pair 2, negative 3 is on this line. So negative 3 for y, 1/4 times 2 for x, plus b. This allows me to solve for b. So negative 3 is equal to 2 times 1/4 is 1/2 plus b. Subtract 1/2 over. So negative 3 minus 1/2 is equal to b. getting a common denominator. This is negative 6 over 2 minus 1/2 equals b, or negative 7/2 equals b. So this whole equation for the asymptote would be y equals 1/4 x minus 7/2. Similarly, we could do the negative, the one going downhill here, by counting, starting at the box at the center and going down and over. So this one has a y equals negative 1/4 x plus b. And again, by similar means, we could plug in our center, which is on the line. So negative 3 for y, positive 2 for x, and that allows us to solve for b. So with a little bit of math here, bear with me. So negative 3 is equal to negative 1/2 plus b. Now adding the 1/2 over, so negative 3 plus 1/2 is equal to b. Again, common denominator, so negative 6/2 plus 1/2 equals b, or b is equal to negative 5/2. So then this formula for our asymptote would be y equals negative 1/4 x minus 5/2. So here's your asymptote equations. For problem number 10, we need an equation of an ellipse. It looks like we are elongated, so the major axis is in the y, the vertical direction. I do know that halfway in between these points would be that center point. So if we kind of think about this, we know that we're going to have a center halfway in between the x values of negative 7 and negative 1 would be that negative 4 here. So this must be the point negative 4. And then halfway between the y values here should be at positive 1. So negative 4 up 1 should be that center point. Thus, I know I'm going to have an x plus 4 quantity squared plus, it's an ellipse, so it's going to be a plus sign in between, a y minus 1 quantity squared equals 1. So all we really need to know are the a squared and the b squared to go underneath this thing. So let's count this, just to get that out of the way here. Let's count this. So in the y direction, so underneath the y part in the formula, I'm going from 1 up to 7. So that value must be 6 there. Likewise, in the bottom, I'm going from 1 down to negative 5. So if the value that I'm traveling is 6, in the formula, we would put a 36. In the x direction, we're going, just for clarity, I'll get a different color here. We're going from here to here. Looks like from negative 4 to negative 1, or negative 4 to negative 7 in the other direction. That's 3 and 3. So in the x direction, so underneath the x in the formula, we should go out 9. So now to figure out the foci points, right, to figure out the foci points, we're going to use the wonky version of the Pythagorean theorem. So c squared equals a squared minus b squared. I generally just pick the a and the b that makes this positive. So I would pick c squared is equal to 36 minus 9. C squared is equal to 27, or c is equal to plus and minus the square root of 27. If you pull out the 9, this would be plus and minus 3 square roots of 3. Okay, so think about what that looks like. If our center is right here, our foci are going to be up 3 square roots of 3 and down 3 square roots of 3 from that center point. So you would go start with your center of negative 4 up 1, and in the y direction, so attached to the 1 of that center, we're going to go plus 3 square roots of 3, and then the other focus point is going to be negative 4, 1. So starting at your center, and you're going to go down 3 square roots of 3 for that focus point. Okay, next. Number 11, we're getting there. Write an equation of the parabola graph below. This has to be an x squared parabola. I know that because we're opening downward. So now I just have to think to myself, okay, it's not quite this simple of a formula because the vertex is at 3, 0. So let's amend this a little bit. This is going to be an x minus 3 squared equals 4p times y minus 0. We really don't need to have the minus 0 in there because we're not off of the axis there. So we really just could keep this at a plain old y. to figure out what the p-value is, I simply have to count how many spaces away my focus and directrix are. So p is equal to 3, but because I'm opening downward, we're going to make it a -3. So then cleaning this up, x minus 3 quantity squared equals, plugging in a -3 over here, this becomes a -12 times y. We don't need to have the -0. Okay, moving right along, number 12. I'm just going to create a little bit more space here. We've got an ellipse, so I know that we are looking for it. It's not asking for it, but I think we should graph this to get an idea of where these points are. So -7 up 4. There's 1 point, and then back 7 up 4. So 1, 2, 3, 4, 5, 6, 7 up 4. And because the focus points are over 5 up 4 and back 5 up 4, I know that this thing is elongated in x. That tells us we've got a center right here in the middle. I'll try to highlight this with a different color. So the center must be right here in the middle of them at 0, 4. So if we go back to our formula, we'd have an x minus 0 squared over something plus a y. We're going up 4, so y minus 4 quantity squared over something equals 1. Remember that the distance in x that we've traveled is out 7, so that's our a value is 7, which means in the formula we would put a 49. We're not quite sure what the b value is, but we do know that the distance to the focus point is c, and that would be 5. So then we can use that wonky version of the Pythagorean theorem to solve for b squared. So a is 40, a squared is 49, c squared would be 25, based on the values above. Swapping places with the 25 and the b squared, we get d squared is equal to 49 minus 25, or b squared is equal to 24. And if I was looking for, more information, I could take the square root, but we really don't. This is the value that goes up into the formula. And so we can just stop here. Okay, number 13. Write an equation for the circle graph below. In order to find a circle, all we need are the center and the radius. The problem is I don't really know what the radius is here. So we're going to have to do a little distance formula for this guy. Make sure that this formula is on your note card. Okay? The radius, that will tell us the radius. The center for this thing is 2, -3. So x minus 2 squared plus y plus 3 squared is equal to r squared. So all we really have to do is figure out what that radius is. So let's do a little bit of work here. The distance, which is our radius, between these two ordered pairs is the square root of x2 minus x1. So 2 minus 0 squared plus y2 minus y1. So -3 minus 1 squared. So then this is going to look like 2 squared, which is 4, plus -4 squared, which is 16. This thing is the square root of 20 is the radius. So when we plug it back into the formula, we have to square it. So we just have x minus 2 squared plus y plus 3 squared is equal to plain old 20. Okay, number 14, write an equation for a parabola that has a directrix at x equals 16 and a focus at 0, -5. I have no idea until I actually get a picture of this thing going. So I would look at this and say, I've got to plot these things. So x equals 16, that's way over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. So I've got a vertical line, x equals 16, a focus at 0, -5. So halfway in between the directrix and the focus should be this vertex point. So what's halfway in between 0 and 16? It would be at 8 and still down on this -5. So my vertex would be over 8 down 5 is your vertex. And the p-value then, right, I don't really need to get a picture of this thing, but the p-value is the distance from the vertex to the focus or the vertex to the directrix. So p would be equal to 8, but again, it's opening towards the left, which is negative, so p is going to be negative 8. So when we put this all together, this is going to be a y squared parabola. So a y plus 5 quantity squared, a y squared parabola, equals 4p. If p is negative 8, that's a negative 32 times x minus 8. Right, so getting those vertex values and our p-value in there. Okay, last one. We're almost there, team. Number 15, what is the center and radius of this circle? Well, it doesn't even look like a circle right now because I'm not supposed to have a number out front. So let's divide this whole thing by 4. So we've got x squared plus y squared plus 4x minus 16y minus 4 equals 0. Let's lump our x's and our y's together. So x squared plus 4x plus blank, I hope you know where this is going, y squared minus 16y plus blank is equal to, I'm also going to take this negative 4 and get it to the other side. So adding that to the other side, I've got a 4, and then plus blank plus blank. So let's do some b half b, and then half b squared. So b is 4, half of that is 2, squaring it is 4. So I'm going to add 4 and 4. With the y's, same idea. I'm going to need the b half b squared. So b is negative 16, half of that is negative 8, squaring it is positive 64. So I got to add that to both sides. So if we clean this all up, this would look like this whole first trinomial is x plus 2 quantity squared. This whole second trinomial would be y minus 8 quantity squared, if we just kind of factor them down. And on the right-hand side, we have 4 plus 4 plus 64, which should be 72. This means that we are centered at negative 2, 8. And our radius is equal to the square root of 72, which is equal to, if we were to break this down, 36 times 2, pulling out the square root of 36, we'd end up with 6 square roots of 2.